Okay, today we're going to continue looking at addition and subtraction of fractions. What's going to be the difference today from what we did yesterday?
This time they're unlike.
Okay, what does that mean, Victor?
They don't have the same denominator.
They don't have the same denominator, right? So, everything that we did yesterday, it's going to be the same idea, but what step will we have to do before we add them?
Make them the same denominator.
Make them the same denominator, okay? All right, let's look at 3/5 plus 1/3. So, 5 and 3 clearly are not the same denominator. Can anybody raise your hand and tell me what I would change those two to get common denominator? Do I need to change both of them? One of them? Well, what would be a common denominator for 3 and 5?
5?
Okay, can you multiply 3 times something to get 5?
No.
So that wouldn't work, so it's got to be bigger than 5. There we go, 15. Okay, so Ethan, what would you multiply 5 by to get 15?
3.
So both of these fractions, top and bottom, get multiplied by 3. What would you multiply 3 by to get 15? What do you multiply 3 by to get 15? 5. Okay, so we'll start back with this first fraction. What's 3 times 3?
9.
So you get 9 over 15 plus what? What's 1 times 5?
5.
So 9/15 plus 5/15. Now does this look exactly like what we did yesterday?
Yes.
Yes, so all you have to do is add those top numbers. What's 9 plus 15? Or I mean 9 plus 5, Ethan.
14. Can we simplify?
Can you simplify 14 over 15?
No. 15 and 5.
Okay, but listen, what happens if we simplify this? It goes right back to where we started, then we can't add them. Okay?
What is going on here?
What's your question, Cash?
What? Did we already do one problem?
I'm sorry?
Did we already do one problem?
No,
and stop?
Well, yes.
I was not paying attention. What happened
Clearly.
there?
Okay. So probably now would be a good time for you to start paying attention, right? Okay, let's look at 2/7 plus 3/14. Can I add those two together the way they are right now? No, because they don't have common denominator. Now, is it possible that I would only have to change one fraction to find common denominator? Yes. Which fraction would I change? 2/7. What do I want to go to for common denominator? 14, right? So what would I multiply by 7 that would give me 14? So I'm going to multiply this fraction, both numbers, by 2. Okay? So 2/7 is going to change to what? 4 over 14. Am I changing the other fraction? No, because it is already over 14. Now can I add them together? Yes. What's 4 plus 3? So I get 7 over 14. Can I simplify?
Yes.
Yes. Say it again, Cash.
1/2.
1/2. So you should always check, because not every time are you going to have to change both fractions. Sometimes you only have to change one. All right? Okay, let's look at -5/6, and we're going to add 1/8 to that. Okay, so I've got to figure out what's going to be common denominator. Now, here's what you have to think about. What I would do is I would think about what are like my multiples of the bigger number, and then stop at when it's also a multiple of the smaller number, right? So what's 8 times 2? 16. Is that a multiple of 6? No. What about 8 times 3? 24. Would that work for 6? Yes. Okay. So what do I multiply 6 by to get to 24?
4.
So multiply both numbers by 4. Let's go ahead and do that. What's -5 times 4? -20. Don't forget your sign. Okay. What do I multiply 8 by to get to 24? What's
3.
okay? What would that fraction be?
3 over 24.
Okay. So now that I have common denominators, I can add those together. But what do you notice that's different about this problem? There's a negative. So what happens when your signs are different? What do you do with the two numbers?
Subtract.
Subtract. What is 20 minus 3?
17. Negative 17 over 24.
How do you know that it's negative, Cash?
When you, add a negative and a positive, it's always a negative.
Not always a negative. You take the sign of the number that's further from
Most of the time.
0, okay? So 20 is further from 0 than 3, so you take the negative to your answer, okay? It's not always negative. That's for multiplication. If you're multiplying and dividing and one's negative, one positive, then yes. But remember, addition and subtraction is different. All right, let's look at negative 3/10 plus negative 5 3/4. Now, let me ask this question. Do I have to change 5 3/4 to an improper fraction?
Yes.
You do have to?
No.
You don't have to, right? Because notice you're adding two numbers that have the same signs. So really, you could just change the fraction part. So what would be a common denominator for 10 and 4?
40.
Somebody over there said it correct. 20. Now, 40 would work, but it's going to be bigger than what you would actually need. Okay, so let's use 20. How do I get from 10 to 20?
Times 2.
Okay, what's 3 times 2? So I get negative 6 over 20 plus negative 5. How do I get from 4 to 20? Okay, what's 3 times 5?
15.
Okay, so since my signs are the same, I can add my whole numbers, add my fractions. So do I need to add anything to 5? Is there another whole number over here? No, so 5's going to stay. What is 6/20 plus 15/20?
21. No, 20.
Okay, what sign should that number have?
Negative.
Positive.
I'm adding two numbers with the same signs.
Oh, negative.
It should stay negative. You've got to keep your rules for addition and subtraction separate from multiplication and division. Rules for addition say when signs are the same, you add and keep the sign. Okay? Would this be my final answer? No, why? Okay, 21 over 20 is equal to what? 1 and 1/20, so you add the 1 to the 5, and then you have the 1/20 left. Okay, be really careful about your signs, you guys. Most of you are going to do fine on this assignment until it comes to writing your answer as negative or positive. That's where I see the biggest mistakes. Okay? All right. Ethan. Okay, what about this problem where you have different signs and you have mixed numbers? What would maybe be the best thing to do on this one?
Do
Yeah, on this one, when they have different signs, I would probably change to an improper fraction. It'll just save you from making mistakes. Now, some of you might need a calculator on this because you're going to get some bigger numbers, okay? What is 6 times 9? 54 plus 8 would give you 62, okay? So, first thing we're doing is just changing them to mixed numbers. 7 times 12 is 84 plus 5. Okay. Now, can anybody tell me, when we're talking about 9 and 12, what the smallest common denominator we should use would be? Think about multiples of 12. Would 24 work?
36.
No. What'd you say, Cash?
36.
36. How do you get from 12 to 36?
Times 3.
How do you get from 9 to 36?
Times 4.
Good. Okay. Here's where you might just need a little bit of calculator help. Somebody in your calculator do 62 times 4.
248.
So I get negative 248 over 36 plus what? What's 89 times 3?
266.
Okay. You are correct. Okay. So I have negative 248 plus 276. My signs are different. What should I do with the two numbers? subtract them, okay? So, what is 267 minus 248?
20-some?
19.
19. Okay, now, before we write our answer, which sign do I take? Which one of those numbers is further from 0?
The negative. Oh, yeah, I said it wrong.
The positive, so it's just going to be positive. Can I simplify 19 over 36?
Yes.
You can? What can you divide 19 by?
You cannot.
19 is a prime number, means you can't divide it. Okay?
That was a hard problem.
No, it just took a little longer than some of your others.
That's why I got a calculator.
Okay. Anybody want to try this one? It's an easy one. Addie.
You change the denominator on the 3/4 and multiply it by 2 to get 8.
Good. So then I would have 3/8 minus what?
6/8.
Okay. All right. What is 3/8 minus 6/8?
-2.
Very good. Now, remember, 3 minus 6 has to give you a negative. What's the other thing you could do? You could change it from subtraction to addition, change the sign of the second number. Okay? 3 plus -6 is also -3. Okay? All right. Last one. Now we'll let you go. Last one. Okay. All right. Let's look at 9 3/5 minus 7 2/3. Now, you can, right? But notice you're subtracting numbers. Remember how we did this yesterday where we just borrowed?
That was kind of hard though.
Okay, I want us to try using borrowing, but first I need to find common denominator for my fraction. So somebody raise your hand and tell me, we really already done common denominator for these two numbers once. What would it be for 3 and 5? 15. Okay, so how do I get from 5 to 15? Okay, so what would be my mixed number? 9 and 9 over 15. Okay, what am I multiplying by here? So I would get 7 and... Okay, so now it looks exactly like those problems we did yesterday. Can you subtract 7 from 9?
Yeah.
Yes, you can do 9 minus 7. Can you do 9/15 minus 10/15?
Yes.
You can?
No.
No. This number, the fraction has to be bigger. Okay, so we're going to borrow. So I drop the 9 to a 8, and then I add 15 to 9. What's 15 plus 9? Okay, we changed to common denominator. Okay, if you're going to subtract with mixed numbers and not use improper fractions, this fraction, the first one, has to be bigger than the second one. Okay, so all I did was borrow from the whole number, add it back in as a fraction. All right. Okay, what's 8 minus 7? What's 24 minus 10? Okay, do I need to simplify this?
No.
Now, if you choose, can you do improper fractions on this problem?
Maybe.
Yes, you're just going to have a lot bigger numbers. That's fine. You can choose to do that if you would like to. Okay? Just make sure you simplify all the way. All right, 18 to 42. That would be a good choice.